The 1988 Seoul Olympic Games marked the return of tennis after a 64-year absence. Miloslav Mečír from Czechoslovakia and Steffi Graf from West Germany won the men's and women's singles gold medals. Since then, tennis has once again been one of the main dishes at the Olympic feast of sports. In fact, tennis featured in the first Olympics of the modern era at Athens in 1896. Among the first women to make their appearance in the Olympic arena were the tennis players in Paris in 1900. However, a dispute between the International Olympic Committee and the International Tennis Federation over the definition and eligibility of professional players led to tennis leaving the Olympic family in 1924. In the course of the next half-century, tennis developed into one of the most prominent, competitive, and richest sports in the world. Wimbledon, the French Open, the US Open, and the Australian Open produced an endless stream of world-class tennis stars. Now, having been reunited with the Olympics, tennis is again exhibiting its appeal on the broadest sports stage and is more popular than ever before. Tennis is at the same time one of the most athletic and the most fiercely contested of sports. The serve of American player Andy Roddick has been recorded at a speed of 246.2 kilometers an hour. Players in moving over the 100 square meter court make use of 640 muscles in every part of the body. A male player, on average, runs 6 kilometers in the course of a match and makes over 1,000 independent decisions. Moving with the speed of lightning, delivering blows with the power of heavy artillery, and caressing the ball to create various spins and points of fall, all these skills constitute the charm of tennis. The intricate mechanical relations between racket, court, and ball have long been the subject of debate and study. The first tennis balls were made of leather stuffed with horsehair, human hair, or rags. Later, a rubber core was wrapped tightly in strips of wool. Modern tennis balls are formed of 2 rubber hemispheres covered by 2 glued pieces of woolen cloth. The size, weight, and elasticity of the tennis ball have to comply with rigid standards. The mechanism of the ball bouncing on the ground is easily understood. The force of the ball impacting the ground will cause a deformation of its shape. The ball will naturally restore itself to its original shape and in the course of doing so will release the elastic potential energy and push itself up from the ground. A tennis ball hits the ground obliquely, and because of the inertial force, it will lose only a little of its horizontal velocity. It will also acquire a vertical velocity component from the resilience force. The moment formed by the spinning of the ball and ground friction will also influence the angle of bounce. After the bounce, the ball loses around 40% of its kinetic energy, which is emitted as heat and sound. The rough texture on the surface of the ball is not merely decoration. By increasing the air resistance, it reduces the speed of the ball. The roughness can also enhance the ball's rotation. According to their elasticity, tennis balls are categorized into various standards for use at different altitudes and on different surfaces. Racket technology is obviously key to a tennis player's performance. In the early days, the frame and handle of the racket were made of solid wood. Later, laminated wood was adopted. In 1965, the first metal frame rackets appeared. Aluminum, magnesium, zinc and copper were all used to produce various lightweight alloys. Since 1980, glass fiber, carbon fiber, ceramic fiber and Kevlar have been used. The regular changes of materials have made tennis rackets lighter and stronger. A racket frame made of these composite materials can bear a stronger tensile force than one made of wood and can thus support a larger head. This in turn enhances the power that can be generated by the racket. As for the strings, originally they were made of goat's gut. However, as the gut was typically less than 8 meters in length, while a racket generally required 12 meters of string, cow gut was adopted instead. Subsequently, a variety of synthetic fibers such as nylon, polyester, and Kevlar were tried. However, in terms of their elasticity and feel, these materials are all inferior to natural gut. The top modern tennis players prefer to use rackets with natural gut strings. But there's a drawback. While high in cost, natural gut is not very durable. The solution is to use nylon fiber for the vertical strings and natural gut for the horizontal strings, as this achieves a complementary effect that increases both the toughness and the elasticity of the racket. The strings need to be tight. However, the effect, known as creep deformation, loosens the strings with time, so that they need regular readjustment. The ideal tensile force of a racket's strings varies from player to player, but there are certain fundamental principles all players must observe. The tighter the strings, the less forgiving the racket face, and the smaller the deformation will be. The reduced contact time with the ball and weaker impact generated allows the player to exert better control over the ball. On the other hand, if the strings are looser, the deformation will be greater. There will be more contact time with the ball and greater impact. But the player will have less control over the ball, and the racket will act rather like a catapult, with the consequent loss of accuracy. In addition, during the contact between the ball and racket, both will undergo elastic deformation. However, the ball will always lose more energy than the racket. So it's more energy efficient to use a looser racket, since this produces smaller deformation of the ball. Roughly speaking, the speed of the ball is equal to the combined speed of the racket swing and elastic recoil. The real secret of the tennis racket is the sweet spot. A ball that impacts with the sweet spot rebounds with the greatest force and yet has little effect on the player's arm. A ball that is struck by a part of the racket head that is far from the sweet spot will not only be returned with much reduced force, but also jar the player's arm. No one has successfully fully explained why the sweet spot is so sweet. But there are some areas of agreement. For instance, the larger the sweet spot, the less the risk of the player suffering from tennis elbow. A baseball bat serves to illustrate the effects of the sweet spot. First, the gravitational center of the bat is found, and then it's hung up handle upwards. Now the bat is struck with a hammer. A blow at the gravitational center moves the whole bat with an equal acceleration. But if it's struck at the bottom, or top, the two ends will move in opposite directions. By varying the point of the blow, the spot is eventually found where the rotational axis of the bat and handle are the same. This spot is called the center of percussion. A ball hit from this center will hardly be felt by the hitter. In the same way, a ball hit from a certain spot on the vertical strings of a tennis racket will not cause jarring or stinging to the player's hand. Strings around this spot also have the highest deformation recovery coefficient. A tennis racket also has something called a vibration node. A ball hit from here will produce the smallest shock. The sweet spot lies somewhere near the center of percussion and the vibration node. The area of the sweet spot has expanded with improvements to the manufacturing technology of tennis rackets and the increase in the size of the head. The reason why serves are becoming faster these days is not just that players are becoming stronger, it's also got a lot to do with the expansion of the sweet spot. The court is another decisive factor in the performance of tennis players. The quality of the tennis court determines how the ball bounces and how the players move. The Wimbledon Championships is the only tennis major that's played on grass. A grass court produces a limited friction force, so that balls travel at higher speeds off it and have a lower bounce. Players tend to spend more of their time in the front court. Grass courts are termed fast, and matches played on them tend to be shorter. The French Open is played on a unique red clay court made of crushed brick covered with additional crushed particles. Players can glide across the court. The clay court has a high friction coefficient, which means that balls come off it slower and bounce higher. Players therefore tend to launch long-range attacks from the back of the court and use a lot of spin. A clay court is commonly referred to as slow, since players have plenty of time to respond to shots, even serves. As a result, matches tend to be seesaw battles.
好球！
The US Open and Australian Open use hard courts made of cement and asphalt, which are covered with paint or rubber. A hard court is a moderate-speed court. Players tend to perform better on one surface than another. Roger Federer, for example, is best on a grass court. Andre Agassi was the king of the Australian Open. And Rafael Nadal is the superstar of the clay court. Today, more technology is making its way onto the tennis court in the form of advanced underground irrigation systems and laser technology for judging line calls. But it's not only the famous players and their sophisticated equipment that are making tennis one of the greatest sports today. It's also the ordinary players on courts from schools in the remotest corners of the planet to the roof gardens of Dubai's 7-star hotels, who are spreading its popularity to every corner of the world.